In today's water drop, we are going to look at InfoWater Pro and hydraulic modeling, specifically how we can create new Python scripts and codes using ArcGIS Pro notebooks in InfoWater Pro. Alright, so who is this for and why should you be interested with it? Well, Python is one of the #1 coding languages in the world. It's used quite frequently for AI and machine learning modeling, and now it can be combined with your hydraulic modeling applications within InfoWater Pro. With this new API built in, again, consultants can use this to generate reports. ArcPy enthusiasts can use this to generate things right directly within your application. It's a great way to bring, again, this popular language into one of the most popular platforms for hydraulic modeling in North America. So the workflow we are going to look at today is, first we're going to look at the InfoWater Autodesk Water GitHub site, where there is a couple example scripts to reference. That's a good thing to maybe bookmark if you want to get into this. Next, we are going to add junctions to our domain in InfoWater Pro. We're going to have a run already set up and run. Add domains to that junction. We're going to utilize the GitHub and a Seaborn website to create an advanced graph. We're going to run that Python notebook. Maybe we'll export some of that data out to a CSV, export the picture out to a PNG, show it inline in the notebook, and then rinse and repeat. This is really meant to be an example to help you customize and further tinker your notebooks to accomplish some of these hydraulic modeling tasks more easily. All right, so here we are in InfoWater Pro, and we're going to walk through this Python notebook within ArcGIS Pro and InfoWater Pro. So you can see I have my model here. I have a number of different nodes in my domain here. These are going to be the junctions that we work with to create a couple of different graphs using the pressure results from this particular month-long simulation. So the way I got to this notebook here is I came over to View and Catalog View, and from here you can go straight to your notebooks, and here I have kind of the library of ones I've gotten from GitHub. Again, our open source GitHub site right here has a number of different codes for Ruby scripting and our other solutions, but we do have some Python examples here as well. So that link will be in the description of this video. But within here, I'm going to look at this pressure graphs from Seaborn, the website Seaborn, which has a number of different examples for how to create some pretty unique graphs that you can use with Python scripting here. So I've opened that up. Here is that Python script that we're going to use to evaluate my junctions here from my domain here on the left. So for starters, a number of different prerequisites. See, I'm importing from a couple of different libraries. Here is where we're specifically calling the outputs from InfoWater Pro's outputs. I'm calling ArcPy there. Here you can see I'm going to be generating all my graphs inline. There are different ways you can create graphs within Python. All of the ones I'm going to create here are going to be inline in this particular notebook. So I'm also specifying the project name, scenario, where that virtual database folder is. So if I hover over my junctions here and everything, you can see where that virtual database is in that file path. And so I'm just setting a few prereqs there at the beginning. So run that, no problem. You can see I've run this before, so I've got some different junctions selected here from my domain. Here is where it's creating that junctions table from that working folder, that virtual database. It's finding those junctions and selecting them based on whether they've been selected from that domain and have that type 1 there. So here I can go ahead and run that. I've got a new list of junctions here, and we move on to the next cell, we call it, in these notebooks. So now we're going to create something called a data frame. So this is an object within these Python notebooks where you can think of it just as a table almost. We're going to be calling data from our out folder and our scenario that I have selected. So this is a month-long simulation I have right now. So if I scroll this over here, you can see I've got 720 hours of model results that we're going to be looking at, and we're calling that out1, okay, and out path. Okay, I'm doing some for loop scripts to get the ID, the time value, and the pressure that I'm converting from head to PSI in here. I'm calling those different values in this for loop here, converting those rows to my data frame here in this data frame, and then I'm creating a couple copies of that data frame for operations we're going to do further down here. So if I run that one, you can see some things here take a second. Boom, I've got my new data frame. You can see that ID, time, pressure, junctions in that data frame there. Okay, next I'm going to recreate this box and whisker plot. So this is kind of a cool plot that again comes from the Seaborn website. So if I drag this into our screen here, here's this whole gallery of different charts you can create using Python script, and the one we're going to be looking at here came directly from this grouped box plot script here. So copied and pasted this in and then populated it with information from my data set here. So instead of using tips data frame, data set, I'm using my own data frame that we just generated in that last command there, in that last cell, I should say. All right, so importing Seaborn as SNS, import pandas as PD, set the theme, and then here is where I'm specifying that data frame df that we created up here. Data frame df, we printed it out here, we displayed it right here, and then I'm calling those different axes here. Here's my pressure, here's the IDs for the different junctions, and specifying how large this graph might be, and then I'm showing it down here below. So if we come into this one, let's go ahead and run that and see how this changes. All right, so a little bit different now. Shows different junctions than before. I've got 6 new junctions in that box and whisker, that max value, min value, and kind of the average in different kind of median values in between there that I can see. Very cool. Pretty unique graph that again I could copy and paste out of here, and we'll see how I can actually export that to a PNG later. So now maybe I want to do something a little different with those pressure values. Instead of just doing the box and whisker, maybe I want to look at the pressure zones and how those compare over time. So to do that, I need information from my IWDB folder, from those actual DBF tables, not the output, but I want the zone IDs maybe here. So here what we're doing is we're converting that DBF table to an array, and then we are merging these two data frames, and that array is then converted to another data frame, and that data frame is then merged to the one we had already created. So here's df2 here, and we can see how this is the data we called from that DBF table, that's in our virtual database there. And we can see the zone ID information and how we join that to our initial data frame here. So if I rerun this, that works successfully here, and you can tell it's not working anymore when that is open, that circle is open, it's not running. And you can see I now have my zone IDs joined to my new junctions here. So with that information, we're going to recreate this graph, which is showing kind of the error bounds and the kind of minimum and max pressures for these different zones here. So again, this came directly from Seaborn. So if I show this briefly, came from this example graph. I simply copied and pasted this into my script. And so not only am I going to show this, but I'm also going to save this to a particular space on near my model, I should say. All right, so this one takes a little bit to run just because it's creating a more complicated plot, I suppose. All right, so we see that graph has appeared. I've got a little more overlap because of the different junctions I selected, so that's pretty interesting, but overall pressure zone 1 still greater than pressure zone 3 when it comes to average pressure within that zone and those couple of junctions I selected there. All right, and in this last kind of bonus cell example, we're building a table based on some of the ranges from the data that, again, we pulled from the output, and we're publishing that to, again, near where my model is on this D drive here. So if I run that, we can now start to see those results populated in that spot here. I have the junction report and the pressure with error bounds here as a PNG. So again, there are many more examples I could walk through, many more ways. I'm sure I could use Python scripting within InfoWater Pro, but hopefully that was beneficial to show how highly valuable Python and InfoWater Pro within ArcGIS Pro can be, how you can start to automate complex workflows. You now have an open source library to go to for these type of scripts, a gallery to go to pull and utilize very interesting and diverse looking graphs to really make your hydraulic analyses pop and enhance your very valuable reporting from your hydraulic model.